What is igneous petrology? Igneous petrology is the field of geology in which we can study the process involved during the formation of igneous rocks. Megascopic, microscopic identification and field examination of igneous rocks are basic techniques used in petrology, and even more we can predict through petrography studies. Modern igneous petrology also relies on experimental investigation of melting. After development of the concept of plate tectonics in the 1960s, a more convenient way to account for the location of much volcanic activities on Earth, because major igneous activities occur near the plate boundaries, like plate divergence or convergence. In table, we can see volcanic are 4 types: basalt, andesite, dacite and rhyolite. Basalt have mineral types olivine, pyroxene and plagioclase. It is mafic in nature with low viscosity and darker in color. The percentage of SiO2 is less than 53%. Andesite having minerals pyroxene, amphibole and plagioclase. It is intermediate in nature with intermediate viscosity and dark in color. The percentage of SiO2 varies from 53 to 63%. Dacite have minerals amphibole and plagioclase. It is silicic in nature with high viscosity, light color, and the percentage of SiO2 varies from 63 to 70%. Rhyolite have minerals quartz, plagioclase and mica. It is silicic in nature, very high viscosity, lighter in color, and the percentage of SiO2 is greater than 70%. Molten mass comprising most abundant elements in Earth like silicon, aluminium, iron, calcium, magnesium, potassium, hydrogen and oxygen, where the SiO2 is most abundant amongst all. Magma is molten rock located beneath the surface of Earth. It can be defined as complex high temperature silicate solution that is primitive to all igneous rock type. It is capable of intrusion or extrusion into crustal rocks. The viscosity of magma dependent on the percentage of silica. Magma, when extruded on the Earth's surface, is termed as lava. The silent features of magmas are as follows. First of all, extensive variation in igneous rocks with regards to mineral composition, texture, variable magma composition, and rate of cooling. Secondly, magmas are usually made of silicate minerals or silicate in composition and usually begin to crystallize at high temperature. Magma have a range of crystallization temperature, like ultramafic magma crystallize at higher temperature as compared to granite. They have sufficient amount of fluidity and contain variable amounts of volatile materials. solid rocks is controlled by three physical parameters, that is, temperature, which is controlled by geothermal gradient, which average is 25 degrees Celsius per kilometer. Second is pressure and third is composition. Magma is generally of four types. First is primitive magma. Magmas that are not very evolved are called primitive. Second is primary magma. Primary magma is that magma which formed at depth directly by partial melting of some source and have no characteristic that reflect the effects of subsequent differentiation, fractionation or assimilation. Third type is parental magma. The parental magma is the most primitive found in an area and thus the one from which we suppose the others are derived. Any primitive or primary magma may be parental magma. Fourth type of magma is derivative magma. Those magmas that experience some form of chemical differentiation are referred to as evolved or derivative magmas. There are three basic types of magma. First is mafic, that is basaltic, rich in iron and magnesium minerals. Second is andesitic, that is intermediate in composition. And third is felsic, that is rhyolitic, rich in light color minerals and silica. Chemically, the magma is composed of silica alkalis like sodium, potassium, calcium and magnesium, and also iron. The more mafic is magma, the gentle will be the eruption, because low level of silica cause less volatiles to be built up. The composition of magma will change depending on the makeup of rocks, that it melts as it penetrates the earth crust to erupt in the form of lava. One more type of magma is ultramafic type, that is picritic type. Observation concerning volcanic eruptions. Viscosity. The resistance to flow determines the kind of eruption and volcanic deposit. Viscosity is dependent on two things, temperature and composition. The higher the temperature, the less viscous is lava. Example is basalt. This is because as the temperature of solid becomes higher, the bonds become weaker. In case of composition, in a melt, silicate tetrahedra become polymerized. That is, they become joined together by sharing oxygens. The more polymerization or the more shared oxygens, the more viscous the magma. Increased silica ions increase the degree of polymerization and thus the viscosity of the melt. Gas content. Nearly all magmas contain gas that evolves at lower pressure as the magma reaches the surface. The same thing happens to carbon dioxide in soda when the cap is removed and pressure is released. The viscosity of magma controls how easily this gas can be removed from the magma. In fluid magmas, the gas can be released easily. Gas bubbles caught in a frozen magma are called vesicles. In a viscous magma, the gas content easily escape. The expanding gas sometimes tears apart the sticky, viscous magma and causes an explosive eruption, where much ash and tephra are erupted. Origin: the magma is produced by melting of rock mass below the Earth's surface under high temperature and pressure condition. That is, it results from the melting of crustal rocks by pre-existing magma whose temperature is greater, that it melts the rocks which come in contact of it. As magma is less dense than its source rock, it is propelled up by the buoyancy that its lower density creates.
Suppose we will see the composition of magma, then we can divide the magma into 4 basic types. One is your ultramafic magma, that is picritic in nature, or in other words we can say that Mg is more in that magma. Then next is your basaltic magma, in which the pyroxenes and calcic plagioclase is more. And the third category is your andesitic magma, in which amphiboles and calcic plagioclase is there. And lastly, the felsic magma. And in felsic magma, the potash feldspar, sodic calcic plagioclase and quartz is there. And suppose we will see the depth wise, then we can see that ultramafic magma generated at more depth with high temperature as compared to felsic. That too right from upper mantle to lower crust.
As magma melts, it reacts with or incorporate material from wall rocks. Its final product is a rock differing in composition from original magma.
The fraction crystallization and assimilation. The fraction crystallization is nothing but especially if suppose we will see the Bowman reaction series, how the olivine is formed, then pyroxenes, amphiboles and biotite in discontinuous series. Similarly, if suppose we will see that olivine crystallized and fractionated due to, or in other words we can say that it is settled due to gravity, then magma is depleted by Mg or Fe component. So in this way that fractional crystallization is very, very important, and due to fractional crystallization the different type of rocks are formed within the same magma. Similarly, the assimilation. Assimilation is nothing but it is a mixing of different magmas and form different derivative magmas.
Assimilation may be capable of significantly altering the composition of magma. Evidence of partial assimilation can be found in variously altered and resorbed contacts or xenoliths suspended in igneous rocks. Two types of contamination are assimilation by melting and assimilation without melting. Magmatic differentiation is defined as any process by which magma is able to diversify and produce a magma or rock of different composition. Differentiation and partial melting involves two essential processes. First, due to intensive change in variable such as pressure, temperature or composition, There is a composition difference between one or more phases, as elements partition themselves in response to change in variables. Second, fractionation is the physical process by which different portions, usually distinct phases, are mechanically separated. Process of development of heterogeneity out of homogeneous body. It is mainly due to liquid immiscibility. Due to difference in density, composition, and volatiles, magma do not mix with each other and separate out. Second reason is liquid fractionation. Only crystal forms separate out. Third is movement of volatiles. Due to the volatiles entrapped in magma, the magma of two different composition mixes and hence separate out. Fourth reason is fractional crystallization. Due to gravity settling of crystal form, selective nucleation, gas streaming, flow differentiation, etc.
Keeping in view of examination for BSc or even in higher classes also, one basic question is asked based on magma, like define what is magma, its composition and evolution. Another question is define what is primitive, parental and primary magma and discuss the evolution of basaltic magma.
The question is why? Where does magma come from? Why there are so many types of volcanic rock? Why do volcanoes erupt? Earth scientists so far study different types of volcanoes, and on the basis of their observation, a wide variety of igneous rocks are known.
For this course module, in which that your introduction of geology, basically for the BSc Part 1 students, magma is a very important topic, because if suppose we will see the definition of magma, magma is a molten rock material within the earth crust. Whatever rock type form later is your igneous, then igneous convert into metamorphic or in sedimentary by different processes. If suppose you will see the classification point of view like intrusive rock or extrusive rock, that all form by the magma. The rock which form within the earth crust is known as intrusive, and those which are formed at the crust or outer surface due to eruption of magma is known as extrusive rock. So that is why magma is a very, very important in geology coursework.